Moving right along with our discussion of IP version 6, we'll talk about IP version 6 addressing basics. Now, as we've mentioned, IPv4 addresses use a 32-bit address space, 4 octets of 8 bits each. IPv6 addresses use a 128-bit address space, and as a result, an IPv6 address looks really more like a MAC address. An IPv6 address, instead of just using the decimal number system, uses the hexadecimal number system, so any letters or numbers 0 through 9 and A through F are valid in an IPv6 address. A sample of the IPv6 address is this. You'll notice that it is 8 sections of 4 bytes each for 128 bits. Now, I know if you're like me, you look at this IPv6 address the first time and you just kind of go, oh my goodness, that thing's 1.5 miles long. How am I ever expected to write that out? How am I supposed to say an IP address like that in conversations? Well, there are some shortcuts to writing an IPv6 address. Number 1, you can drop any leading zeros from the address. My sample address doesn't have any leading zeros, but if there were leading zeros, you could just drop them entirely because all you're really interested in are the most significant bits towards the right of the IP address. A group of all zeros can be abbreviated with a double colon, but only once in each IP address. Again, since an IPv6 address follows a known format, if you have a bunch of zeros right here, you can just do colon colon and it knows, well, I've got 1, 2, 3, 4, 5 sections. There's going to be 3 sections of zeros that he cut out by using this double colon shortcut. So as an example, the IPv6 address FE80, all those zeros with this address at the end, can be shortened to FE80 double colon 1, because again, you can drop any leading zeros in each octet or each section, DC1 2345 1234. So this big, long, nasty, scary address can be shortened to something that's a lot more readable and a lot easier to write. Now, much like IPv4 addresses, IPv6 addresses can use a slash notation as a shortcut to refer to entire ranges of addresses. For example, this IP address here is in the network 2340.1111 1423 and a whole bunch of zeros, or if you follow the shortcuts that we mentioned on the previous slide, that's the actual subnet for this particular IPv6 address. Again, much like a /16 or a /24 network, you can have a /64 network and just basically cut the address in half. The second half of it is all zeros, just like in an IPv4 subnet. Now, there are 3 different types of destination addresses in IPv6. The first, like IPv4, is a unicast. A single device receives the packet just like on IPv4. The second is a multicast. A group of devices receive the packet, again, just like IPv4. It's very similar, built on the same principles, so no need to be scared about it. The third type of destination address is an Anycast. An Anycast routes the packet to the host that is topologically closest to the requester. This is not really used widely on IPv4 networks because it tends to break state in connection-oriented protocols. Where you will see Anycast addresses is on load balancers, and again, load balancers is well beyond the scope of the CCNA, but it's worth mentioning anyway. Now, what type of address is missing from this IPv6 list? That's right, broadcasts. There are no broadcasts in IPv6. Everything is a unicast or a multicast. I attribute that specifically to the size of the IPv6 networks. I mean, would you really want to broadcast to potentially however many millions or billions of hosts that this network would entail? I don't think so. So now let's talk about IPv6 address types. The first one we'll talk about is a global unicast. These are very similar and are identical, in fact, to public IP addresses in IPv4. They come from the range 2000, and all of the rest of the addresses follow 2000. So if you see an IPv6 address that starts with 200, then you know it's an actual public IP address. It's not private to any particular provider. There used to be a type of IPv6 address called a unique local or a site local address. Now, they have just done away with the site local addresses entirely because people have realized, why do I need private IP addresses? I have enough IP addresses to give everything in the world several 100,000 IP addresses. Why do I need a private range? The third type of IPv6 address, or I guess the second type of IPv6 address, is a link local address. There's not really a true analog in IPv4. You can kind of correlate it to a private IP address, but it's not really a private IP address because they're only for a local subnet. They're not forwarded at all by any IPv6 routers, even if they're not really public routers. I'm using air quotes around public like you can see what I'm doing here. Now, link local addresses can be calculated by hosts on their own. In fact, on my Windows 7 recording machine here, I am not running an IPv6 network here at home, and yet it has calculated its own link local IPv6 address. You notice it starts with FE80, and in fact that is my next point here in the PowerPoint deck. These addresses come from the range FE80/10, and you'll notice that even though the IPv6 address in the command window had lowercase letters in it, since it is a hex number, it doesn't really matter if it's lowercase or uppercase, either one will work. So enough with the prefixes. What about the last half of this IP address? You've been hiding it from me, and I've purposely not talked about it because the last 64 bits are the interface ID. It can be anything that you care to assign to it so long as it's globally unique. This address is normally based on the MAC address of the adapter. IPv6 splits the MAC address in half and inserts FFFE in the middle of the MAC address. For example, this particular MAC address that I just pulled out of the air becomes that IPv6 address. You notice 944452FFFE-BC1BFE. So that's how a MAC address becomes the last half of an IPv6 address, and that would actually be a link local IPv6 address there. This is called the EUI64 format, and this is the method that hosts use to calculate their own IPv6 address, their own link local IPv6 address. And that concludes our discussion of IPv6 addressing basics.